Hey everyone. So we've learned how to use aggregate functions to perform calculations based on a set of data. So, for example, if I look at my SKU data, I can count this and say I have 8 items. So let's do that. This is just a minor review before we go on to the actual topic at hand, but I can say select count from SKU data, and it'll tell me how many items I have. And the answer is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's good. So this works on the whole set of data. And that's fine, and it's a start. And there is some information that you can extract with this. But there is a trick that you can perform for aggregate functions. And to lead you to what we need that trick for, let's ask ourselves, okay, but how many items belong to Jerry Martin? Well, that's easy. I can perform a count where the buyer is Jerry Martin, and that'll limit it to only returning these 2 fields, and it'll count them and tell me that Jerry Martin has 2. So let's try that. And remember, I'm putting the buyer's name in quotes because it's a string, single quotes rather. Jerry Martin. If I run it, it tells me he has 2 items, which is correct. If I look at the data, I can see that Jerry Martin has 2 items. It's what we discussed back when we were first looking at this. So, okay, the boss tells you, but I want to know what everybody else has too. And so you could look at this and go, oh gosh, now I got to write all these SQL queries. One for Cindy Lowe and one for Nancy Myers and one for Pete Hansen, and I got to remember which one's which and all that mess. And that's true, you could do that, but that's not thinking efficiently. There's a way to make SQL group that data for you. And the way that we do that is using the group by clause. So, what it does is it allows you to perform aggregate functions on groups of your data rather than the whole set. So just to explain what that means again, if I wanted it to tell me how much each of these buyers had, I use group by for that because I want to group the buyers together and then tell me how much each of them has. And I know that sounds confusing, but hopefully the demonstration will help iron that out for you. Where it goes is after the where clause, or where the where clause would go if you had one. So, let's say I want to do, this selects how many records belong to Jerry Martin. I run it, I get 2, yay. Now if I want to say I want to know the buyer as well as how many records belong to it, this query, the select is correct, but you're missing a critical piece of information. If I run it, it'll tell you buyer isn't part of an aggregate function. Anytime that you use an aggregate function in a select query and then non-aggregate data with it, you have to group it. So what I want to do is say how many items belong to each of my buyers? How many records belong to that person? And I look at this and go, well, they each have 2. Well, there's a way to get the database to tell you. So I want the buyer and how many records they have. And that's what's in my select statement. But in order to do that, it has to go, okay, Pete Hansen, these are the Pete Hansen records, count them 2. Nancy Myers, these are the Nancy Meyer records, count them 2. And that's what the database will do. So it needs to know what piece of data you will be grouping by. And that's explained by what we just did here. Cindy Lowe. These are the Cindy Lowe records together. There are 2 of them. So we grouped it by the buyer. Now we don't have a where clause here. So because of that, we can just do it right after the from. If we had a where clause, that would have to come first. So group by buyer, because that's the data that we group together and then we count them. So let's try this. Cindy Lowe has 2 items. Jerry Martin has 2 items, and so on and so forth. It grouped the data and it sliced the data up into little subsets for us and then performed the aggregate function on that. And it used group by to do that. So let's say department instead. I want to know how many items belong to each department. Well, we can do that too. Department and then the count from SKU data. So it should tell me that water sports has 4, camping has 2, and climbing has 2. So if I try to run it, it'll fail. And it tells me department is not part of my aggregate function. Well, right now, what I'm trying to do with this function is I want it to tell me the departments and how many records they have. But I'm trying to group it by buyer, and that's not correct anymore. I need to slice it into little subsets for the departments. I want all of the water sports records together so that Access can count them and tell them that there are 4. I want all the the camping records together so that Access can count it and tell me that there are 2. So that's the data I'm going to group by now. Select department. How many records belong to them? Group by department. Okay. So I run it. And it tells me how many records belong to each department. Now you can perform grouping based on more than one field at a time. Let's see, what would be a good one? Oh, we could do order number. I want to know how much each order is in total. So for example, these 2 records belong to order 1000, and looking at the extended price, we can see that the total will be $430. But let's see if we can get the database to tell us what all of the orders were. So order item is going to be our table, and our field is going to be, let's see, what is it? Order number and the sum of the extended price. Now you notice I didn't use count this time. If I used count, it would just tell me how many different items were in each order. That's not what I wanted. I wanted to know how much the total order amount was. Now we're kind of working the long way around in this one because that's actually stored in the retail order table. I know that. Wait, why does that say that's 445? Aha! This is a great example of why you don't store calculated data in a database, because now there actually is something wrong. So I know that it's going to be 430 total, but that's not what this says. So how are you supposed to know what's correct and what's not? It's a great example of why you don't store calculations, the results of calculations in a database if you don't have to. So the order number and the sum of the order. I want to know how much I've made off of each order. And in order to do that, I'm going to have to group it. So I'm going to group my orders together and then have it tell me how much for each of them. So group by order number. I run it and it should tell me, yep. Let's see if there are any other order 2,300. Yep, this is also incorrect. Maybe that includes shipping. That's not listed here in the retail order. Oh, this one's actually smaller than what's in there. So yeah, there are definitely some data discrepancies in this database. And as a person like us who go in there after the fact, we're not the person who entered this data or who handled these orders. So now we have no idea what's correct and what's not. So let's determine another thing. We're going to go back to SKU data here. And I mentioned to you before, if I wanted to know how many records belong to each buyer, I can do that. Count from SKU data, and we group by the buyer because those are the little groups of data we're going to be counting up. It tells me there are 2 for each of them. If I want to add department to it as well, I want to know what department those belong to. And I hit run, it's going to whine at me because I didn't group by department. Anything that you don't group, if you're going to do this, you're going to select data with aggregate information, you have to group the data. Everything that's not aggregate has to be in your group by or it doesn't work. So that's a little shortcut for you guys to know. If you're selecting data along with aggregate information, everything that's just plain data has to be in your group by. It must, or the database engine will whine at you. So we run it, and there are 2 camping Cindy Lowe's, there are 2 climbing Jerry Martins, yada yada. So that's an example of how grouping works. So come back later, and we're going to begin looking at joins. Well, I'll demonstrate one more thing. Grouping works well. Everything that we've gone over so far is designed to be combined. You can do grouping and sorting at the same time. You can do calculations and grouping at the same time. You don't have to do all these things individually. So we've already learned that sorting is done by the order by clause. So let's say, actually I want to look at the data again first. Run it. I want it sorted alphabetically by the buyer because that's what the boss wanted, and to present an unalphabetized list is something that some bosses might gripe at. Oh, that sucks. They already are sorted alphabetically. Well, for this example, let's do reverse alphabetical. So I'll do order by buyer. Order by does our sorting. And if we leave it like this, it's not going to change anything because it was already sorted alphabetically to begin with. If I want it in reverse alphabetical, I add a special keyword after the field. And if you've been paying attention and taking notes, following along, you know that keyword is DESC for descending. So I want it to group the data, count it, present it to me, and then sort it in reverse alphabetical order on the buyer. Ta-da! So this is a great example of how we will be using these concepts together to perform information gathering from the data.